It started with a blurry shape on a satellite image barely noticeable to most, but enough to ignite a firestorm in the scientific community in the middle of an arid desert region. A researcher using Google Earth spotted a series of unusual patterns carved into the landscape. What caught their attention wasn't a modern structure or natural geological formation, but what appeared to be the outline of a gigantic skeleton. Could this be the remains of a prehistoric creature, possibly even a dinosaur, visible from space? It sounded unbelievable, even absurd. But the more scientists examined the coordinates, the more questions emerged. Was it just a natural rock formation, or something more? The discovery triggered online debates, with some paleontologists urging caution, while others entertained the possibility that we might be looking at the world's largest exposed fossil. If true, it would challenge everything we thought we knew about fossilization and how we find dinosaur remains. How could a fossil this large remain undisturbed and unnoticed for so long? And how could it be visible from orbit, when most fossils are buried under layers of earth and rock? This is the story of what happens when cutting-edge technology meets ancient secrets buried beneath the surface of our planet. The first step was to verify the satellite imagery. Scientists from several universities downloaded high-resolution images from multiple sources, including NASA and ESA satellites. They used image-enhancing software to clean up the visuals and compare them with known fossil sites. What they found was shocking. The structure did resemble a skeletal layout, with what could be interpreted as a skull, spine, and even limb-like extensions. Though many geologists warned that erosion and wind patterns could create such illusions, others remained intrigued. The fossil appeared to measure over 30 meters in length, larger than most known dinosaurs. A team of independent paleontologists proposed a field expedition to the location, but getting there wasn't easy. The site was remote, located in a politically unstable region with little infrastructure. Permits were hard to obtain, and local authorities were skeptical. Meanwhile, the internet buzzed with theories. Some claimed it was a new species of sauropod. Others suggested it might be a hoax, a clever manipulation of terrain images. Conspiracy forums went further, proposing ancient civilizations or alien activity. But real science required boots on the ground. And in early 2020, an international team finally arrived at the coordinates. What they uncovered would either prove the skeptics right or change paleontology forever. The expedition team, armed with GPS tools, drones, and ground-penetrating radar, began their investigation with methodical precision. The first few days were spent clearing debris, mapping the site, and collecting soil samples. At first glance, the bones were disappointing, just eroded ridges of rock, bleached by centuries of wind and sun. But beneath the surface, things became more interesting. Radar scans revealed anomalies just below the crust, dense structures that didn't match surrounding geology. Could these be fossilized bones? The team dug cautiously, knowing that real fossils are fragile and easily destroyed by improper handling. After 2 weeks, they struck something different, a dark fossil-like segment embedded in sediment. Tests showed high levels of phosphate and calcium, classic fossil markers. More segments followed a possible femur, vertebrae, and what looked like a jawbone. It was still too early to declare a new species, but excitement grew. The bone arrangement was unusual, not quite like any known dinosaur. Some features suggested marine adaptation, like paddle-shaped limbs, while others hinted at a land-dwelling predator. Could it be a transitional species, a missing link, or a completely new branch of the dinosaur family tree? The discovery posed more questions than answers, but one thing was certain: something ancient had once lived here. As excavation continued, media coverage exploded. Headlines screamed, "Dinosaur fossil visible from space, a new species discovered by Google Earth." The scientific team, meanwhile, tried to maintain cautious optimism. Early analysis of the sediment suggested the fossil dated to the late Cretaceous period, roughly 70 million years ago. This was a time when dinosaurs roamed the Earth in enormous variety, and sea levels were much higher. Could this creature have lived near an ancient shoreline that later became desert? The fossil's location aligned with a now extinct inland sea, which gave weight to the theory of a semi-aquatic dinosaur. But the biggest surprise came from the teeth. Embedded in what was believed to be the skull were rows of conical teeth, not flat like a herbivore, nor blade-like like a typical theropod. These teeth resembled those of fish eaters, suggesting a piscivorous diet. That narrowed down the possibilities. Some scientists compared it to Spinosaurus, but the skeletal proportions didn't match. Others speculated it might belong to an entirely different group, perhaps an undiscovered branch of marine reptiles, or even a post-dinosaur species that survived extinction. As samples were shipped to labs across the globe, peer-reviewed studies began to form. The world watched as experts debated what exactly had been uncovered back in the lab. Carbon and isotope testing further confirmed the fossil's ancient age, but it wasn't just the age that fascinated researchers, it was the preservation. Fossils of this size and completeness are rare, especially in open, exposed environments. Typically, bones degrade quickly without the protective layers of sediment, so how had this one survived intact and visible from orbit? A new theory emerged. Perhaps the fossil had only recently been exposed due to shifting sands, erosion, or even climate change. Satellite archives were reviewed, comparing images over the last 2 decades. Strangely, the fossil-like shape didn't appear in earlier images from the 1990s or 2000s. Only in the past 5 years had the terrain begun to shift enough to reveal the outline. This supported the idea that the fossil had remained buried for millions of years, only to be revealed by nature's slow hand. But some scientists weren't convinced. They argued that this might be a pseudo-fossil, a rock formation that merely looks like a skeleton. Still, others were struck by the anatomical symmetry, the spacing of ribs, the curvature of the spine, the alignment of limbs. Could nature really be that precise by accident? The evidence was building, but the scientific community remained divided. One of the most hotly debated aspects was the fossil's authenticity. While the discovery had excited many, it had also triggered skepticism. Was it truly a biological fossil? Or was the shape simply a trick of erosion and imagination? Some critics pointed to similar phenomena in other parts of the world. Geological formations that mimic living shapes, like the elephant rock in Iceland or the dragon's spine in China. Could this be another example? But others countered with structural analysis. Using 3D modeling, paleontologists reconstructed the site digitally and found consistent bone-like proportions. More intriguingly, the fossils lacked certain mineral deposits found in non-biological rock, suggesting an organic origin. And then came the bombshell: one fragment sent to a European lab tested positive for preserved collagen protein, extremely rare, but not unheard of. If verified, this would all but confirm that the structure was once a living organism. The presence of collagen would place the specimen in the category of exceptionally preserved fossils, comparable to those found in amber or permafrost. The stakes were suddenly much higher. Museums began to show interest. Scientific journals competed for publication rights. And yet, a nagging question persisted: why hadn't this fossil been discovered earlier if it was so enormous? The answer, ironically, may lie in our assumptions about where to look. Paleontologists often search in areas with exposed sedimentary rock, typically cliffs, canyons, or riverbeds. But satellite imagery has opened a new frontier. With global scanning tools, remote sensing, and AI-assisted pattern recognition, we can now analyze vast areas of Earth's surface from space. This case served as a wake-up call: how many other fossils might be hidden in plain sight, simply overlooked because they don't fit our preconceived notions. Some scientists began calling for a fossil census from space, using satellite data to identify fossil-like anomalies across continents. NASA and private companies like Planet Labs started sharing historical data to aid the effort. In fact, one student in Australia found a similar formation in the outback using Google Earth and machine learning algorithms. The implications were revolutionary. Fossil hunting, long limited by terrain and manpower, might enter a new age, one powered by orbital archaeology. But, as always, technology only gets us so far. Validation still depends on human observation, careful excavation, and peer-reviewed science. The dinosaur fossil spotted from space wasn't just a scientific mystery, it had become a symbol of the future, where satellites and spades work hand in hand to uncover our planet's past. Public fascination soared. Documentaries were announced. Social media buzzed with amateur theories and armchair paleontologists. Some claimed the fossil proved dinosaurs were larger than we thought. Others tied it to ancient myths, suggesting this was the origin of dragon legends. One conspiracy channel even claimed it was proof of prehistoric giants that coexisted with early humans. But behind the noise, serious scientists continued their work. Paleontologist Dr. Elena Torres, who led the on-site dig, emphasized caution. "We're at the beginning of understanding this fossil," she said in a televised interview. "It's not just about the bones, it's about context, ecosystem, preservation, and time." Meanwhile, debates intensified over classification. Was this truly a dinosaur? Or could it be a marine reptile, like a mosasaur or plesiosaur? The presence of certain bone structures like hollow chambers and dense vertebrae suggested a hybrid lifestyle, perhaps an evolutionary offshoot we hadn't cataloged. Universities began requesting access to core samples. Virtual symposiums were held to share findings. And throughout all this, one idea kept returning: what if this fossil wasn't unique? What if it was just the first of many massive fossils visible from space? That possibility ignited a sense of wonder and a global race to scan Earth for the next clue. As more data poured in, a surprising conclusion began to emerge. The fossil wasn't entirely unique, but its visibility from orbit would, in fact, buried fossils of similar scale likely exist around the globe. But changes in climate, erosion, and satellite technology had finally aligned to make this one visible. It was a perfect storm of conditions. Researchers proposed the term orbital fossil visibility window, a brief moment in geological time when conditions make deep history briefly observable from space. This idea transformed how scientists viewed landscape changes. Shifting dunes, drying riverbeds, and melting permafrost could reveal secrets previously hidden. And this wasn't limited to dinosaurs, mammoth bones, early human settlements, and even ancient forest beds might be next. Some even speculated that other planets like Mars could reveal similar windows of ancient life. If only we knew where to look. The fossil from space had opened a conceptual door Earth itself was offering us a glimpse, a fleeting moment to witness what had been lost for millions of years. And it wasn't just about bones, it was about history speaking through geology, waiting for us to listen. For scientists, this was no longer just an excavation, it was a planetary conversation across time. So what do scientists say today? Most agree the fossil is real. The visibility was rare, and the implications are profound. Peer-reviewed papers are now being published. With more fieldwork planned, Dr. Torres's team is returning with additional funding to expand the dig and study the surrounding area for more fossils. Museums are preparing exhibitions, and educational platforms are updating their digital maps. The discovery has sparked a quiet revolution in how we approach fossil research. It's no longer about what we can find in front of us, but what we might see from above. Satellite-assisted paleontology is now being taken seriously, and universities are investing in interdisciplinary programs that combine earth science, space technology, and AI. But for many, the most powerful takeaway is not scientific, it's emotional. That a creature from 70 million years ago could reveal itself in our modern era, using tools it could never imagine, is a poetic reminder of how little we truly know about the past.